How does anything heat up this fast? We're not heating water, we're not heating food, we're heating the thermometer to see how fast it goes from tap water or room temperature up to the temperature of this water, or theoretically, the temperature of food. But my question is, because the thermometer seems to move the needle faster when it's going to a higher temperature, does it take the same amount of time to go from cold to hot if it has a larger span of temperature to cover versus a smaller one? So that's why I'm timing these. What do you think? Does it look like it takes a little bit longer for one or the other needle to finish reaching equilibrium? And one thing I do know is that the last few seconds, the needle going to the higher temperature is moving faster still, covering more degrees. So I might want to look at that one a little longer before determining what temperature is equilibrium. Now, why should you care how long it takes a needle to stop moving when you're measuring a thermometer in water? Well, I did a variety of temperatures of water for this test to see how fast the needle would go in hot and cold. But this next temperature is a little bit more important because it represents the safe food temperature for beef, well-done beef, about 170, 169. So most meat's going to be very well done, cooked, safe if it gets to this temperature. So what I was thinking is I could say, I don't want to wait 20, 25 seconds to know how hot the meat is. If I can just count the first 15 seconds and see if it gets past this certain point, it's going to reach 170. That was the whole point of this video to begin with. That's what got me started. Now in this case, it looks like it took only 6 seconds to get past 160 and another 6 seconds to get to 169. So instead of waiting 12 seconds, I could just say, hey, if this needle takes 6 seconds to get past 160, it's going to be safe for the meat. Now your thermometer might be different and your room temperature might be different, so this won't work for everybody, but that's what happened here. Another important thing to remember is that dry foods or foods with air gaps or fat will transfer heat more slowly than moist food or liquids. And that brings us to another important lesson about how you measure the temperature of your food. I didn't always know this, but you're not supposed to measure food after it cooks. You're supposed to put the thermometer in while it cooks. And that's great for oven-safe thermometers, but not all thermometers can go in an oven. And what do you do with a microwave? Well, definitely don't put a metal thermometer or a digital one into a microwave, but what you have to do, because it heats unevenly anyway, is stop and mix the food and check it in different places, and then cook some more and keep checking until it's evenly cooked all over. Well, that's about all I have to say about this. Thanks for watching. Did I miss anything? Stay tuned for more random gadget demos.